Welcome to the support tutorial video for Bruker handheld products. This video will review the library matching feature in Artax software, and this feature allows the user to build a library of known reference materials and find the best match for unknown samples. Before getting started, a quick word on data management. When all the raw data is eventually collected and stored, they will need to be separated into different groups, and the groupings will be company specific based on the end user needs. But some examples would be grouping them based on chemistry, or grouping by different sections of the manufacturing floor, or by different manufacturing components. So in this example, I will group the data by source and name them company A, B, and C. I will also have a separate folder for all of the unknown samples. The first step is to collect the raw data for all of the reference materials and all of the unknown samples, which in this case I've done ahead of time. However, when doing so, it's important to ensure that the analysis surface of all the samples are clean and to pick an area on the sample that is as smooth and flat as possible. Also have any coatings or paint removed as possible. On the other hand, if the sample is too small, it's recommended to place the sample between two layers of XRF film, such as ProLean or UltraLean, and clamp it down using XRF sample cups. That way the sample can be placed on the desktop stand and centered on the instrument window. For the instrument parameters, it's recommended to use the Alloys 2 application. And then in the settings, set phase 1 to about 60 seconds and leave phase 2 off at 0 seconds. It will be crucial to collect all raw data for references and unknowns using the exact same conditions. For this example dataset, we will assume that we have to match unknown scrap metals to reference materials coming from company A, B, or C. However, raw data collected on the handheld XRF is given a default and numbered file name. So after all the raw data is collected, the next step is to rename all of those PDZ files to a name that better identifies the material or chemistry. So in this example, I've already organized the spectra into their respective folders and renamed them according to their alloy ID designation. I also have a separate folder for all of my unknown samples, which do not have to be renamed. Next, we will open Artax, and this is located either on the desktop as a shortcut icon, or it's in the main Bruker folder. Both the username and the login password are both test. And the first step in Artax will be to open the first group of PDZ files. So in this example, that will be for company A. So we go to the top menu and select File, Open Spectrum, and then navigate to the appropriate folder where the PDZ files are stored. Highlight the relevant ones, and then at the bottom, hit Select, and then Open. This will overlay all of those PDZ files together, and the drop-down list at the top will show their names and their color codes. From here, we go to the top menu and hit Project, and then select New Project. On the left side, in the Objects folder, right-click and select Add Spectra. Then we can hit this arrow icon, and it shows a drop-down that can confirm the PDZ files which have now been added to this library. From here, we go back to File, Save Project As, and we will give this library a name, and then it will store this as a .rtx file, which will be the library for this particular set of PDZ files. Hit Save, and now that library is stored. This procedure will now be repeated for company B and C. So first, close out this project by going to the top project menu, and then select Close Project. Then, in the Spectrum Viewer window, select the Close All Spectra icon to clear out all prior PDZs. Then, as performed, it will search through all libraries in a given folder. For this example, I have been storing all libraries in a single folder location, so that when a match is performed, it will search through all libraries for company A, B, and C at the same time. The other option is to store each RTX file in its respective group folder so that when performing a search, the user will then select which individual library to search from. Once all libraries have been created and stored, exit the project window by going to Project, Close Project, and clear out any existing spectra from the spectrum viewer. Now we are ready to open the unknown sample PDZ file. So we go to File, Open Spectrum, and find the folder where the unknown samples are stored, and select one of the PDZ files to open. From here, go to the top menu and select Analyze, then Match. This opens the Match Settings window. The first step in the match settings is to point the software to the directory where all of the RTX files are saved. This relates directly to how the libraries were saved in the previous step. If they were all stored in one folder, then you can point the match routine to that folder and the software will run through all of the libraries. However, if stored in separate folders, the user will have to select the individual library to use. To do so, click on the folder icon on the right-hand side, and then navigate to the appropriate folder. When found, then hit Select Folder. Other parameters are the start and ending energy, which is the active energy range used to compare the spectra. Generally 4 to 19 keV is sufficient, but this can be adjusted to include lighter or heavier elements. The user can also set the minimum correlation value required to validate a match. And then the number of hits will define the number of matches reported. When finished, click Start. The results are now shown in the Match Results tab in order of their correlation percent. Based on how I chose to name these files, the column labeled Spectrum will show the specific alloy ID designation, and then the column labeled File Name will show the source or company. So for this example, the first match is for alloy CDA510 from company B with a correlation of 99.9. Each set of samples may have a different range of correlation values. Alloys tend to have higher values that fall within a narrower range. In addition, by double-clicking on any one of these matches, the spectrum viewing window will automatically overlay that sample with the match so that a visual comparison can be made. To go back to the matches, simply click on the Match Results tab. To perform a new match, simply go to the Spectrum tab and clear out any existing PDZ files, and then open the next unknown sample. Then go to Analyze and select Match, and confirm that the directory is correct, and then click Start. And our results show that the first match is for stainless steel 347 coming from company A. And then if we double click that match, we can then see the overlay. In this case, it would be a good idea to pick a representative peak to then normalize the two spectra. If the user would like to add any PDZ files to an existing library, simply clear out any existing spectra from the spectrum viewer, and then go to File, Open Spectrum, and then select the PDZ file you would like to add. In this example, I will select stainless steel 321 and open that. Then go to File, Open Project, and then select the library file that you would like to add this to. In the Objects folder, right-click and Add Spectra. And now you can see that stainless steel 321 has been added to this list. Then go to File and Save Project As, and then just overwrite the existing project file. And now that P2Z file is included. To export these results into a report, select the Match Results tab, and then go to the top menu and select Export, then Copy Result, and now the results are ready to be pasted in any document such as Excel, where the results will be pasted in the same format as they were displayed in the software. This concludes the tutorial for the spectral matching feature in Artax. Thank you for watching and have a great day.